Hi, my name is Jonathan Eves. Thanks for joining me for this demo on how Cisco TrustSec can help to reduce the possibility of compromise on your network by mitigating malware propagation and containing ransomware attacks. The demo covers an attacker using Kali Linux to scan the network to try to find vulnerabilities in remote systems. When TrustSec enforcement is in place, then scanning techniques are blocked and the attacks are unsuccessful. When TrustSec enforcement is removed, however, then the demo shows how a particular threat vector is utilised to compromise a remote machine. This is a diagram of my setup using a software-defined access environment, or SDA, orchestrated by DNAC. The demo could equally have been shown using Identity Services Engine and network devices outside of a fabric, but thought it would be useful to include the orchestration in operation. I have a virtual network, VN, otherwise known as a VRF defined, called development. Within that VN, I have a VLAN provision from DNAC with an ID of 1023. A user has authenticated with Identity Services Engine and been authorized into the Developers Security Group, or SGT8. I also have another VLAN within the development VN, that's VLAN 1024. And a second user is authorized in this VLAN with the same security group as the first, i.e. developers, or SGT8. When the left-hand fabric edge node, here is a 3850 in my case, has learned of resources it needs to protect, then it downloads the required policy from Identity Services Engine, but only the policy that is needed. And this is a snippet of the policy matrix in Identity Services Engine, which has been orchestrated by DNAC. The policy matrix column protecting the developers group here is downloaded, and the particular SGACL that is relevant in our case is the SGACL sourced from the developers group here, destined for the same group here, developers at the destination. This SGACL is what DNAC builds as permitting HTTPS but denying all other traffic. So you can see it permits UDP destination 443 and TCP destination 443 but denies all other traffic. In the demo then, this left-hand PC becomes compromised, maybe through phishing attacks, or maybe it's a disgruntled employee, and further attacks are generated from here to try to compromise other devices in the network. These attacks are generated using Kali Linux. And Wireshark has been installed on the destination VLAN to capture any attack traffic that may reach the target machine. So let's jump over to DNAC then. And out of all these applications, we're going to choose the policy application. And then we're going to jump from policy to the policy administration. And here I'm going to show we don't have any policies added currently in DNAC. So I'm jumping over to Identity Services Engine, and I can show what that means in ICE. Showing the policy matrix, you can see that there's no policies therefore added into ICE, and particularly from developers to developers, or SGT 8 to 8, there is no policy. And therefore there should be no policies in CLI of the switch. On the 3850 we'll just have a look at the role-based permissions, and we just have the default rule in there currently, which is a permit. No other particular SGACLs or policies added into the switch right now. So let's go back to DNAC and let's add a policy, or initially we're going to add a contract, which is an SGACL. So we'll add a contract, and you see the implicit deny there is a deny rather than a permit, and we're going to add this ACE. We're going to give it an appropriate name to permit HTTPS only, and under the port and protocol we can type in HTTPS and it will be found. We can select it and add that, so we have an SGACL within DNAC. So that's the contract added. Now what we can do is under policy go to policy administration to add a policy. So on the right here we'll add a policy, and we're going to drag two scalable groups here, so the developers as the source and developers as destination. And we're going to give it an appropriate name, and we can add a descriptor, a description should we wish to, and then we can choose the contract that we've just added. So let's choose the permit HTTPS contract and let's save it. So this is now a policy that's been added in DNAC, the policy between developers as a source and developers as destination to permit HTTPS only. So what does this mean in ICE? So again, in ICE, if we refresh the TrustSec policy matrix, we can see there between developers and from developers to developers, we've got this policy permit HTTPS. And to actually look at the SDA ACL itself, we can go to the security group ACLs, and there it is. And this is the content which has been provisioned by DNAC. So what does that mean on the switch then? So the switch does have these users authenticated, so it should have downloaded the policy, and there it is. So we have the policy actually resident on the 3850 itself. So I just want to show that in the destination VLAN we do have Wireshark running here to pick up any attacks that we might see in the destination VLAN. So this is Kali Linux. It's perhaps being used by our disgruntled employee. We can do an Nmap intensive scan, and now we can put in the subnet we want to scan, which is 10.440/24, and see what happens. Let's see if any traffic gets past this TrustSec policy through the switch. You can see the Wireshark on the right, it's running. There's no traffic we can see there, but you can see it is running scans, and you can see it's discovering open ports on certain IP addresses, 10.4.4, 1, 2, and so forth. But there's no Wireshark traffic being shown there for our particular client under test, which has got an IP address of 10.4.4.5. So it's still scanning. Wait for it to finish. There, the scan is now complete. And you can see the endpoints that have been detected. But if I scroll across, you can see that 10.4.4.5 has not been detecting itself. Our client under test in the destination VLAN, protected with our developers TrustSec group-based policy, has not been detected. So let's now go up to DNAC and delete the policy. So here's DNAC. We can see the policy here. If we select the policy and delete it and save, you can see it's now removed. So what does that mean for Identity Services Engine? Let's go to ICE. We'll again look at the TrustSec policy matrix, and from developers to developers, SGT 828, the SGACL has now disappeared. So DNAC has removed that from ICE, and in terms of CLI on a 3850, let's refresh, and you can see the policy has indeed disappeared. So now we don't have that protection anymore between these clients in the developer group. So let's do an intensive scan again for 10.4.4.0, that's our destination subnet, and see what happens. Now immediately you start to see traffic on the right hand side for traffic destined for our client under test. It's discovering open ports, and now you can see it is discovering open ports on our client 10.4.4.5 in particular. So again, we can wait for this to be completed, but you can see the traffic that is being shown on Wireshark towards our remote client. So it's continuing its scan, finding out the information that it can from our remote client. There, the scan is complete, and now Kali does show 10.4.4.5 has been detected. It's got the icon, and it shows that it's an XP machine. Now I can do a Metasploit framework scan and discover more information about this endpoint. So again, it's sending more information. You can see on Wireshark. You can see there the TCP ports that are open. It's doing some further discovery. Let's wait for it to complete. Okay, it's now complete, and if I hover over there, you can see it now shows XBSP3. So it has discovered, more information about Servicely, that it's got a Service Pack 3 on there. So what attacks can I do from Kali Linux to this one machine? So what I can do is attacks and find attacks, and now Kali will go for its complete database, all of the attacks it knows about, and see which ones are relevant to this client that it has now discovered. So we'll wait for that to complete. It's now complete, and now we can see all the attacks that we can use on this one machine. If we right click on this client, it lists a number of things that we can use to attack this machine. Now, one attack under SMB is MS08067net API. It's a particular attack, and what I can do is set a reverse connection so that I can bring information back from this machine once I've sent this payload across. So I'm sending this payload, waiting for it to complete, and there you go. Payload's installed. I've got a reverse connection back from it, and I now basically own this machine. So to show that I own it, I can go to this interpreter, I can do an explore, and I can explore a screenshot, for example. But before I actually click on this, let's go over to the client itself and see what's on the desktop there. So let's say an employee is editing some credit card information on the desktop. So it's just got this file open. You can see there. So let's go back to Kali and do the screenshot. So down to Explore Screenshot. It'll open a tab at the bottom here, and there you go. It's brought the screen back, and you can see exactly what the employee is doing. You can see that this credit card information is being edited. Now, something else I can do through Interact is open a command shell. So we'll open a command shell to the client machine. We can change to the root. We can do a dir and have a look at the files, and then do a more on any files. So more the my credit card file, and there you go. You can see the credit card information in that file, and you can see the expiry is 2016. So if we go over to the client, so the employee is now going to save this new information. You can see it's expiry 2023. Let's go back to Kali, do a refresh, so do a more on my star, and you can see, the file has been received. So the client under test is now infected and can potentially infect further machines, spreading malware and ransomware payloads. This demo has shown the effects of allowing the likes of malware and ransomware to propagate through your network, and how this can be mitigated using Cisco TrustSec technology. So that completes the demo. Thanks very much for listening. For more information, visit www.cisco.com/go/TrustSec.